Hello and welcome back, PreAlgebra. So, this week's instruction is all about solving two-step equations. Now, what does it mean by two-step? It means it takes two steps. And so, that also is talking about the number of operations involved. Each action, each step is its own operation, is its own action. And so, in the example we see here, we have addition and we have multiplication. And so we have two operations we are solving, we're undoing. And so that's two steps in order to accomplish. Now, how do we do that? Well, if I'm honest, you can choose either operation to solve first, but one is harder than the other because one involves actually tracking more things and trying to take care of more things and has a little bit of a conceptual leap there. So if you want to see the other way to solve, watch my next video, because in this video we're going to solve by tackling our addition and subtraction first. So first we take care of our addition and subtraction, and then second we'll take care of our division. So, what does that look like in this problem? Well, in order to solve, like we've talked about in previous videos, we want to make sure we're doing the same thing to either side of our equal sign. And so we have the left and right of our equal sign here. And we want to take care of our addition and subtraction first. And so we'll want to subtract by our 4 on both sides. Why are we subtracting? Because subtraction undoes addition. If our goal is to get x by itself, we want to take the adding by 4, subtract it by 4, so we end up with 0. And so then on the other side, we'll have 14 minus 4. And so let's go ahead and rewrite that. We have our 2x untouched equal to 14 minus 4, which is 10. The plus 4 minus 4 is 0, so we say that cancels out. That eliminates. Now we just have 2x is equal to 10. We've taken care of our addition and subtraction. Now we want to take care of our division. And so, why are we dividing? Because division undoes multiplication. Multiplication and division undo one another. Division is all about separating into groups. Multiplication is all about putting groups together. And so in order to undo multiplying by 2, we want to divide by 2. And that's going to get our x by itself. That leaves us with just x equal to 10 divided by 2, which is 5. And just like that, you are in great shape. So, ladies and gentlemen, a couple of things that I want to point out. In this problem, we took care of our addition and subtraction first. The best way to track that is to organize your work. These are pretty easy, nice, simple numbers, which is absolutely wonderful. But remember, I'm not teaching you how to just work with easy, simple numbers here. If the whole world worked with easy, simple numbers, the world would be a much easier place. But instead, because there are going to be numbers that we don't know how to tackle in our heads and aren't intuitive, we want to be able to organize our space so we can have the numbers be the least of our concerns, right? So by organizing the space and tracking our steps, we're able to make sure we have the right answer in the end. And so as you guys are working through this yourself, as we add more steps to our solving for 3 steps or 4 steps or 5 steps, right? You're able to manage that space and manage your work so you're actually able to read through the work that you've done and find any mistakes that you make, because mistakes happen and mathematics is very punishing about it. So that's why we're so careful with our steps to make sure if we do make a mistake, we're able to fix it, because it's absolutely imperative we fix those mistakes. So next, here I wrote the actual equation on the left and the numbers on the right. But ladies and gentlemen, I want to be able to stress that this is the exact same example as 14 equal to 2x plus 4. Which side the 14 is on does not matter because all of the steps between these two examples are exactly the same. And so you still subtract by 4 first. You still divide by 2 first. The only thing that is different is which side your 14 is on. That's it. So when you go to subtract by 4 first, you subtract by 4 and we'll line it up underneath the plus 4 so that way we can track our work. And then the other minus 4 is going all the way over there under the 14. So you can see that where I wrote the minus 4s are different, but that's it. Exact same step, exact same numbers are lined up. And all of the work after this is the same as what I just modeled. Now, let's go and take a look at another example here. So just to help illustrate how all the steps work and how the problems are laid out, let's go ahead and tackle this problem here. 3x minus 7 equal to 20. Remember, the 20 could have been on the other side, and that's absolutely all right. Still solved the same way. Ladies and gentlemen, you can draw the vertical bar. That's going to be helpful for you. I'll model it here, or you can solve it without the vertical bar, as long as you're tracking where your addition, subtraction goes, and where your multiplication and division goes. And so, here's the vertical bar. Zoom. Ladies and gentlemen, let's take care of our addition and subtraction first. Here, we are subtracting by 7. So what undoes subtraction by 7? Adding by 7. So we want to add by 7 to both sides of the equation. That leaves us with 3x equal to 27. And so then the last step here is to get x by itself. And we'll get that by undoing our multiplication, dividing by 3. Calculator geniuses, you'll be able to work out the next step here. 27 divided by 3 is 9. And that's how we're able to get to our final answer there. Excellent, brilliant, wonderful. So here's an example where we had subtraction and we solved it by adding. Up above, we had an example we were adding and we solved it by subtracting. Ladies and gentlemen, I have 2 more examples I want to toss at you today. So the first one is this. Negative 2w plus 11 is equal to 27. Ladies and gentlemen, you may notice 2 things here. One, the 2 is negative and that's what's being multiplied. That's going to be a slightly different step, not because of the action itself, but just because of how we're calculating it. We have to track a negative here, which is an extra thing to do. It's still a 2-step problem that we're solving. The other thing is that there's a w here, and hopefully by now you're looking at that w and completely unfazed that it's not an x. If you're looking at that and going, wait, why isn't that an x? The thing you need to know is that a variable can be any letter, and it's still treated and solved just like it was an x. So let's go ahead and tackle this the exact same way we've tackled all the problems that I've modeled up until now. Actually, ladies and gentlemen, because of the fact that I haven't modeled one like this yet, I want to go ahead and switch the sides and have 27 equal to negative 2w plus 11, just so you can see when modeled all the way through. Shoom. So let's go and take care of this first, ladies and gentlemen. We take care of our addition and subtraction first, so we're going to subtract by 11 on both sides, which leaves us with bum-ba-da-dum. No 11s on the side with a negative 2w because they cancel out. 27 minus 11 is 16. And that 16 is equal to negative 2w. So, ladies and gentlemen, how does the negative get involved here? Well, the exact same way as if it was positive. We care about the fact that the negative 2 is being multiplied by w. And so we undo that multiplication with division, and we divide by what we're multiplying by. If we're multiplying by negative 2, then we divide by negative 2 in order to get w by itself. And so when we take 16 and we divide it by negative 2, our answer, 16 divided by negative 2, is negative 8. A positive divided by a negative is a negative. 16 divided by 2 is 8, and that's equal to w. So our value of w is equal to -8. Now, ladies and gentlemen, let's go ahead and tackle the last one here. I'm going to add on another page. Boom. And so, when we look at this last example, it really is just a reminder. This is a pleasant reminder of how to work with zeros. Ladies and gentlemen, when you have an example, and I'm going to go ahead and use the first one here, 2x plus 4 equal to 0. 0 does indeed mean nothing. There is nothing there, but because there's nothing there, it is a placeholder. So whatever we do to it, it's going to be the value that we're doing. So another way to explain that is 0 plus anything is whatever that thing is. 0 minus anything is whatever that thing is. And so when we go to subtract by 4 on both sides here, it is just 2x equals -4. The 0 is just a placeholder, and so 0 minus 4 is -4. The same thing's true if we have 2x, but then I add 0 to equal to 14. That 0 is a placeholder. Nothing's there. But the good news is that because 2x is being added by 0, we don't really have an action. We're adding by nothing. So nothing's happening. So we can ignore it. We can rewrite it without that addition by 0 there. So our first step is just 2x equals 14. Because adding by nothing is nothing. Nothing's there. And so 2x is equal to 14 is where we end up then with our next step. In both of these examples, 2x equals -4 and 2x equals 14 are problems that we practiced and reviewed a couple weeks ago when we solved with multiplication. So, ladies and gentlemen, I hope that gave you the bits and pieces that you needed in order to tackle this. If you get stuck or have any questions, you can either wait till Wednesday when we all meet together, or please absolutely reach out to me through email, and I'll be glad to explain it and help you guys out. Good luck, and I look forward to seeing you all soon. Take care.